right? So let's say that you have a road that needs built. Okay, so you have a ranch. Okay, and there's a highway here. And there's town. Okay. Let's say that the highway speeds 110 kilometers an hour. Okay. And the road here is going to be a 60 kilometer hour speed limit.
Is there any particular reason why you're doing kilometers?
Because the metric system's better. That's a 30 kilometer distance. And this is 50 kilometers. Okay. Where should we route a straight road from house to highway? To make the fastest trip possible.
So are we trying to get to the town fastest?
Yeah.
Oh, so this like this would be finding this.
So
like,
where are we gonna put the road? From the ranch house to the highway?
This is a right triangle problem, isn't it?
Partly. Yep.
I'll just which one? And then be around halfway.
Okay, so, maybe, but you have different speed limits. So you wanna spend as much
Oh.
time on this as possible, right?
Yeah.
So at some point, the road's gonna be somewhere, a hypotenuse of a right triangle, right? So we need to define a variable for this distance. What, just call it this. Right? You know, that's 30x 50. The 50 is that distance. Okay. What is this distance?
The optimal distance from the house to the highway.
That you have stuff you can put into the Pythagorean theorem, right? That distance would be the square root of 30 squared plus x squared. Right? Okay. Do you remember how to calculate speed? We want to optimize the speed, right? So you can tackle this two ways. You can go with maximum speed, average speed, or you can go with shortest trip time. The speed's gonna be easier. Okay. So do you remember how to calculate trip distance and rate and time?
That's using velocity and acceleration. Right?
Nope. Not that difficult. You don't know dirt, do you?
Minus distance.
Oh, distance equals rate over time.
Yeah.
Dirt.
Okay, so we're gonna use that. We're gonna optimize rate, correct? So the rate is distance over time.
You know, that like sixth grade concept.
No. Such a lot of sense. Or sorry.
That was like the sixth grade.
Something's not right here.
Yeah, we had no
We need to optimize time, because we have rates, right?
Mm-hmm.
But we don't know what the time is. Okay, so time. Distance over rate, okay.
Wait, why is it distance over rate instead of rate over distance?
Because
Right,
rate
I'll buy by hour.
times time for distance,
Oh, okay.
so.
Okay, so what is the distance over rate from the ranch house to the highway?
30 kilometers over 60 kilometers per hour.
And that would be the D equals root 30 squared plus 2, or plus.
There's ranch, right, ranch road,
Yes.
correct? Plus, okay, what about the town? What's the
50.
distance to the town?
50
minus
kilometers.
X.
D over.
Minus X, right,
50 over.
Oh.
50 minus X.
over 110.
Okay.
Okay. There's our function that we have to optimize for minimum time, correct? So the challenge in these is setting it up.
Yeah.
After you set them up, it's not really that big of a deal. I mean, that's not a fun derivative.
Well, we gotta derive that?
Yeah, you have to optimize,
Oh, no.
minimize, right? Minimize time.
Ooh, so you have to derive it instead equals 0?
I have a question. Why can't this now be canceled out by the 34 and the next one?
You can't do that across addition,
It's not.
Oh.
remember?
You just kill the kitten.
We killed a puppy dog in first hour, now we're killing a kitten in second hour.
No.
It's escalating.
Mine's a hippo.
It's gonna be a lion next to the greenies are gonna go nuts. High school math teacher kills a lion. All right, so what's the derivative?
That's a good question, sir.
Math.
1/2.
30 squared plus X squared negative 1/2 times 2X times 60.
And X.
Isn't that Pokemon?
Yeah, but that was just.
No, there's no variable in the bottom.
Oh, it's not Pokemon. Darn.
No, it's just a constant.
That's.
It's gonna get 0 as your derivative, right?
Totally.
Yes, okay.
Please release the band members that are traveling today.
Bye-bye.
Go Cardinals!
Don't win.
Nothing to school.
Huh?
Yes, that was
We have to do 4 of the bands to qualify, so hopefully we will.
You will.
We will. Happy day.
The office or something?
I don't think so.
Okay, you okay with that derivative?
Which one? The writing? Okay. I think we're taking it over.
Oh.
All right, let's,
Oh, that's a plus. Man, your T's and plus sign are confusing.
my T's have a tail, my pluses don't.
Your T's don't always look tail. You
Yeah,
try,
that's
but.
I see tails. I don't know what you're talking about.
Okay, maybe when it's a plus sign followed by a negative number, so it looks like T minus.
It doesn't have a tail.
have.
Don't make fun of me, this is your problem. Okay. Let's go X over 60 root 30 squared plus X squared minus 1/10. Is that a
I think you
correct
abandoned the 2x.
simplification? Hey,
Can I say this? Or what that was?
put it on my desk.
I think you abandoned the 2x though.
I didn't, because there's a divide by 2.
Oh, I see.
I was wondering where that went.
Yeah.
Okay.
I actually marked that on my list before I did mine.
Okay, so we have our derivative simplified, right? Now what do we do?
Set equals 0.
Really?
Yeah,
Find a minimum.
minimum.
Oh, that,
I wasn't joking when I said you said.
I thought you just took a random, like, just guess. Like, it usually works, but.
Oh, goody.
It's simple, just ugly.
It's not simple.
Oh, no, it's gross.
You just multiply all of that over.
We cross multiply.
Pardon? Still looking at right now.
Oh, you did, okay. Hey, what'd you do? Cross multiply. You went like this, multiply this, and then this. You did that? I genuinely never learned that.
But how does that cancel anything?
It doesn't. It's solving the equation.
Wait, but now you don't have denominator, or you don't have numerator as denominator.
Right, exactly. There are fractions
But how did
anymore.
you get there? You.
No, cross multiply. Or you can multiply each side by each term. Right, multiply by 110,
Yeah.
multiply by 60 root 900 plus x squared.
But how do you know to cross like that instead of like that?
Because if you go the other direction, you end up with fractions still.
Oh, yeah. That's your point.
I think we should just stick this year. What's 110 divided by 60?
You're saying drawing that down is the algebra.
11 sixths, 1 and 5 sixths.
Okay, what did you just do in the?
Okay, how do I solve a radical function?
Oh, there's one, okay.
You kill it,
You square.
squared, yeah. Oh, 121 over 36 squared. This is
Disgusting.
not, no fun. I hope it's right.
Oh, you have to square the 11 sixths as well.
Yeah.
What?
Go the old stairs by here.
Copy dot flip.
What the?
985 36.
I'm just trying to figure out where the expert.
He subtracted it. So 121 36 became 85 36. X squared.
He got rid of the third, okay.
Because he turned it into a fraction.
Yeah, it became 36, 36. Gotcha.
This question.
Ooh, gross.
So this is not how it would probably happen in the real world, because you don't want to cross your fields and pastures,
You wanted to grid.
right? Most likely you'd grid this out, unless there were hills and stuff. But 19 and a half is x. So you would need to have 19.5 kilometers here and 30.5 here to optimize your time travel.
You wait, say it again. Say it again.
So 19.5 is our x.
It was.
That's where time is at a minimum. So x is 19 and a half. That's this distance. And then that means that distance to town would be 30.5 kilometers. not uncommon for a farmer to have to drive like that. I know. That's not far off from how far we are from Junction. There's just mountains in the way.
Okay. That's good news.
So how do we know that's optimal?
It automatically spits the ends out, that's right. You can do site analysis if you want to find that it's a minimum, but.
Because you just saw for a critical point, you didn't see if it was a minimum.
No, it's the only one though.
I know, but it could be the maximum time, not the minimal time.
Do site analysis then.
No, I'll take it.
That's funny. Okay, so yeah. Okay, you could do electromath to verify this. All right. Let's do one more. You think? I don't know if we have time. There is a can problem in the book.
So can?
Yeah. Design a cylindrical can of volume 900 cubic centimeters so that it uses the least amount of metal. So you have a given volume of drink, use the least amount of metal. So we have a can. Okay, we want to minimize. I guess minimize this two eyes now. Metal. Okay, so that's a volume measurement, right? That is a surface area problem. Okay. So we have to use both formulas here. But which one are we going to optimize?
Surface area.
Yeah, this is our optimization. Okay, do you remember surface area of a cylinder? There are 2 pi r squareds. Plus pi r h. 2 pi r h. Okay.
Wait, what? 2 pi r squared h or h?
2 pi r squared plus 2 pi r h. The pi r squareds are your top and bottom. This is your sides. How many variables do we have here?
2 r and
Yeah,
h.
we don't like that. Okay, so we have to get rid of one.
Okay.
Okay, so we're going to use volume to get rid of one variable. Okay. So 900 is pi r squared h, right? Because we know the volume of the can.
But in terms of h or r, it doesn't matter.
H is easier.
Oh, yeah, that's true.
Right.
Oh, English.
Sub. I'm going fast, so are you keeping up?
Yes.
So rewrite with the substituted value.
I'm not very familiar with box spaces.
Now we only have an R, right? And I would rewrite this. The pi r's cancel out, so you end up with 1800 over R.
R squared.
What do you do with that?
You derive it.
And
set
find
equals
the-
0.
Yep, minimum. Derive set equal to 0. Find the minimum. So you'll find the minimum value of the radius. You also need to plug radius in to find height. And you got your can size. Okay. Which tells you how much metal you need to use. Right. I'm gonna stop there. Any questions? Okay, again, it's a challenge in setting the problem up. Past that is derivatives, things you know. Okay.
So if you're gonna do distance traveled of an object, like as in a physics problem, how do you do that with calculus?
I'd have to see it. Whoops.
I don't actually use it.
Okay, let's shut this off first.